Hi everyone, today we will be looking at the problem Sprint 27 from the contest 12221. The problem reads, Rudy enters the number 1892 into his calculator and presses the square root button. He then adds 1892 to the result and presses the square root button again. He repeats the process a dozen more times, always adding 1892 to the result of the square root and then pressing the square root button. The final number displayed on Rudy's calculator is nearest to what positive whole number? Well, let's first visualize what this question looks like. We have 1892, then we take the square root of it. Then we add another 1892, then we take the square root of that. Then we add another 1892, we take the square root of that, and so on and so forth. And I'll add the dots at the end over here to show the so on and so forth for, well, countable infinity. Okay, this is what the number looks like. Then let's define the idea of convergence, which is here on the screen. Convergence is as we do an operation over and over again, the result becomes closer and closer to a certain number. Why? Well, as we do an operation over and over again, if this operation has a slower and slower rate of growth, i.e., as a number slows down its growth after a certain amount of operations, then it's going to converge because it's not going to grow infinitely fast. It's going to slow down its growth. And when it's slowing down its growth, it's going to become closer and closer to a certain number. And this applies to our number over here. But why? Well, you see, every time we add a 1892, the number grows. But the number doesn't grow that fast because we take the square root and when we take the square root, all of the numbers here, all of the numbers that are already under a square root become smaller and smaller. So the rate of growth, you can think about it, becomes slower and slower. And therefore, this number converges. Then let n equals to the number we drew, the number here. If we let n equal to this number, which is where we apply it a very large amount of times, where we apply the operation a large amount of times, then when we apply the operation one more time, it's not going to significantly change the number. Therefore, we can write that 1892 plus n is equal to n, where 1892, the square root of 1892 plus n is equal to the operation applied one more time to n. Then we can solve for this equation. We first take the square of both sides. This gives us 1892 plus n is equal to n squared. Then rearranging, we get n squared minus n minus 1892 is equal to 0. To solve this, which is a basic quadratic, let's first find the prime factorization of 1892, which is 2 squared times 11 times 43, and that factorization would be 43 times 44. Now, this isn't something that I just know off the top of my head. You would have to do this in contest, but it's not that difficult to do. Then this means that this quadratic factors into n plus 43 times n minus 44, which is equal to 0. Giving us the results of n equals to negative 43 or n is equal to 44. Thankfully, we don't need to consider both of these solutions because n is a large square root. As you can see, everything is taken under the square root sign there. That means that it can't be negative because you can't have the square root of something be negative. Therefore, our answer is n equals to 44. Let's take a look at the answer choices. The answer choices, obviously, it's not going to be 47, 46, 45, but why isn't the answer 43? Well, first, applying the operation 2 times and then a dozen more times, i.e. 14 times, is already a large amount of operations, meaning that the convergence is starting to take place. You're going to see that it will tend more and more to the number that it's supposed to tend towards after infinity. So 14 times is a lot of times, and you can trust your gut on that. However, if you have the time within the contest, you can observe that 43 squared is 1849, and 44 squared is 1936. So 1892 is about halfway between these numbers. And what that means is that if 1892 is already around halfway between these two numbers, if we apply this operation, i.e. we keep adding to the square root of 1892, if we keep adding to the square root of 1892, then we're going to end up becoming closer and closer to 44 and not as close to 43. So that's just another piece of intuition that you can use. However, if you don't trust either of the methods we've shown to convince yourself that the answer is 44, let's prove our work using a calculator. However, reminder that this is the sprint test, and the sprint test is definitely non-calculator. This is just an example, an amusing example to be able to verify our work, but please do not use a calculator on the actual sprint exam, especially not the calculator that we will show you. So here we are to do our calculator demonstration. Remember, the problem is asking us to take the square root of 1892, then add 1892, then do that over and over again. Now, I'm just going to do this first. I'm going to take the square root, then I'm going to copy it in 14 times. Since in the problem, it's done 14 times. Okay, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So you can see it would be quite, it wouldn't be very fast to use a calculator either. So it's bad to use a calculator. And we just add in the 1892 until we get to the last bracket. This is going to take a while. This is quite tedious. Imagine how bad this would be on an actual calculator. And we've reached the end. Let's calculate this. As you can see, the input looks absolutely disgusting, but we get 43.9999999. That's a very large amount of nines. So basically 44. And this proves the exact same result that we had when we did it without a calculator. Remember that you're not supposed to use a calculator, but we've used a calculator here to show you that the non-calculator version of our answer was correct. Thank you all again for joining the presentation. I hope you all have a nice day.
Hi, everybody. This is Tim. Hope you're enjoying our videos. If so, you know what to do. Like, subscribe, turn on notifications, all that sort of thing. But what I'd really want to invite you to do is to send us an email at media@mathleague.org. Tell us which problems you'd like to see us cover next in our video series. Take care and see you in the next video.